Hello, my name is Nicholas DeCola. I'm a principal program manager in our cloud security engineering. And if you're joining us for part 2 of this session, great, welcome back. If you're joining us as the first time, this is Architecting SecOps for Success, Best Practices for Deploying Azure Sentinel. So if you didn't see the first session, I highly recommend you go back and see some of those other best practices, but we'll continue covering some of the other best practices for Azure Sentinel in this part 2 session. And we will also turn it over and show our Azure Sentinel hackathon winner, and they'll demo what they built for their solution. It's really cool. You'll want to watch it. So moving into data visualization, once you have your data in, you may want to monitor it in a manner to see how much data is coming in, what type of events you're having, and those types of things. And so our best practice here is to really use built-in workbooks as a starting place, right? You can take those workbooks and customize them if you have to as a next step. But they'll give you a lot of good sources as a really good starter. And then obviously you can build your own. I do want to highlight, we released a new workbook called SOC Efficiency Workbook. And this is really awesome because it shows you how many incidents were created over time. You know, what type of rate are you closing these incidents in terms of how long it's taking? Also, what types of closing is it? Is it a false positive? Is it a true positive? So you can really see what kind of incidents you're getting, how they're being triaged, how fast they're being triaged, and really manage your SOC efficiently. Lastly, if you have a user that's outside of Azure, maybe they don't log into Azure, you can also use Power BI to connect to Log Analytics and pull that data in and build that dashboard outside of Azure if you need to. Please share any workbooks that you build that are cool with our community. We'd love to see community contributions in these workbooks. And again, it gets better with the power of community. So moving into response, we use Azure Logic Apps to help respond to incidents inside of Azure Sentinel. And so we have a nice integration where you can automatically run playbooks as part of an analytic. You can also manually run those if you want to triage or enrich more data to an investigation that you're doing. And we have many templates in Azure GitHub that you can use as a great starting point. And again, I'm going to highly encourage that you contribute and share those playbooks back to our GitHub community. So let's demo a couple of the playbooks and see how they can really help you in your environment and response. So here we are in our Azure Sentinel community repo. If you scroll down, we have a folder called Playbooks. And here you can see all of the different playbooks that are available for you to deploy in your environment, some with third parties, some with first parties. Some of these are response, some of these are enrich, like this one is pulling tenable vulnerability information and bringing that back into Azure Sentinel so you can use that to enrich your incident. But let's just show you what it might be to deploy one of these. So I'll just click on Confirm AAD Risky User. And you can see we have a nice ARM template deployment. And with each of the READMEs, we try to give you a quick button to deploy this to Azure or Azure Gov. And so if you click this, it will pivot over to the Azure portal. And it will populate that template in. So I can quickly just select a resource group. So maybe I want to deploy this to, actually, let me pick our SOC. To our SOC, I can rename the playbook if I don't like the name that's there. And then you will need to provide, based on the connectors, you know, it needs a username and a password, or username, sorry. So I would put in my admin account. And so you can hit review and create, and it would go deploy this in your environment. You can also edit the template if you need to. You can also view these templates in our GitHub repo, but we make it very easy for you to deploy. But I'm going to go ahead and deploy this one. So I'm going to say review and create. Just like any ARM deployment inside of Azure, you'll be taken to the deployment. You can see that it's in progress. And you can see the different resources that are deployed. You can see that was very fast. I didn't have to create this template from scratch or build this playbook from scratch. And so now I can go to that resource group. And if I do the confirm AAD Risky User, here's that playbook I just created. So I can click on that playbook. And when you deploy playbooks, they use these API connections to allow connections to other resources. Now, this one only uses Azure Sentinel, but any API connections will need to be authorized. So after you deploy using the ARM template, you will come here, you can click Authorize. You'll be prompted to sign in. And so I'll just sign in as my admin account, and I will save that. And now this connection has a successful OAuth token that can be used inside of the playbook. And so let's dive in and see what this playbook looks like. So if I click edit, I can quickly see I've got this playbook. It was very fast for me to deploy. And so every playbook has to start out with a trigger. So something that makes that playbook run. So our first one is a Azure Sentinel alert is triggered. Next, we're getting the incident properties. And I want to show that with each step, there is some type of output dynamic content. And so here in my dynamic content list, I can see all the dynamic content that was provided in the previous step. So it provided workspace ID, resource group, subscription ID, which are properties that I need to populate to do the get incident action. And so you don't have to like manually statically type in the subscription ID because it might be different for every workspace that you're using. And so the dynamic properties make it nice and easy for you to drag and drop or just click these and add them in where you need them to your thing. So next, I want to get all of the accounts that are involved in the incident. So I provide the entities dynamic content to get the list of accounts. And then because there could be multiple accounts that are part of that, it creates a loop for each account that is part of those accounts. And so with Graph Security API, there's a beta API that you can use to confirm their risky user in Azure Active Directory. So I leverage their beta API, and I'm using an expression. And expressions allow you to do all kinds of things. Concatenate, you can get time, you can convert different things just by using these functions. And so I'm using a concatenate statement to bring together here the account name and the account UPN suffix because you need to provide the actual username here to get the ID. So once that's returned, there's some JSON data that's returned, and you can go look at the Graph API to see what that looks like. And so you have to parse that data out so that I understand the ID. And this parse allows you to create dynamic content based on what's returned from the previous step. And so now when I go to my next step, which is the actual confirm compromised API, here you have to provide a list of user IDs. And so you can see that in my dynamic content, because I parsed that JSON, that ID is now a dynamic content that I can use. And so I just dropped ID in here. And so when I run this, it will actually get each user's ID. It will parse it out. It'll get their actual AAD ID. And then it'll say confirm compromised for that user ID. And again, you can manually call these, or you can have this automatically run as part of an Azure Sentinel analytic. So let's go look at another playbook. So if I go into playbooks in Azure Sentinel, I'm going to pull up one of our other integrated ones. And so we can see here this get MD ATP investigation package. If we click on edit. Again, here you can see we're using the Azure Sentinel alert is triggered. We're getting the incident properties, and then we're getting the host entities. And then we've created a variable. And so this variable is called machine action status, and it's just a string. And we're starting out with a value of null. So again, because there could be multiple hosts, it has to run a loop for each host. And Defender ATP has a nice connector with many actions that you can use built into logic apps. And so here we're providing the MD ATP device ID. We're adding a comment as it's a required field. So we're saying this investigation package was run from a playbook regarding this incident, and we're providing the number and the title from the Azure Sentinel incident. And then based on the return status, which is a dynamic content from the previous collect investigation package, we're setting that status as a variable. Now that status could be success, it could be failure, it could be running. And so then we added a loop to wait until this is actually succeeded. And so we will loop and we'll ask for the status of this action. So it's called get single machine action. And then we give it the action ID. Again, this was a dynamic property that was returned from our previous collect investigation package action. And then we'll update that variable. So we'll keep setting it until it says succeeded. Once it says succeeded, we'll continue, because once an investigation package is created, then there is a download URL that is provided. So here you can do the get action to pull that URL. We're adding a comment to the incident with the actual URL in case the analyst is working from the URL. And lastly, we're posting a message in Teams that says, hey, the investigation package is ready for download, and here's the URL. And again, we're using the subject regarding the number and the title of the incident. So again, this makes it very easy. You would have to go to Defender ATP, click collect investigation package, wait for that to happen. Now you can let that run in the background while you continue to triage and look for other things. And then once that's done, you can go click the URL and download that investigation package and do your further investigation. So now that we've finished our demo of playbooks, we'll turn it over to our Azure Sentinel hackathon winner. Arun and his team have created an awesome solution on top of that. It was part of a hackathon project that we hosted, and it's great to see that the community is contributing these types of solutions. So I'll turn it over to him so he can demo his solution.
Thank you, Nicholas. It was a great session on what Sentinel has to offer and where it is positioned in the modern SIEM landscape. Hello everyone, my name is Arun Mohan. I'm the founder of AdFox and OpsBrew. AdFox is an engineering services company in the cloud native space, and we have a product factory to build tooling to complement cloud native technologies. OpsBrew is one of the products the product factory churned out and tried to solve the evolving and dynamic logging challenges. OpsBrew recently won the Azure Sentinel hackathon and has been a great experience and exposure to showcase OpsBrew features and capabilities to experts in the security domain. Let's quickly get into some details of how OpsBrew can help in your journey to adopt modern SIEM solutions like Azure Sentinel. Nicholas had covered a scenario of log ingestion to Azure Sentinel using Logstash, and basically these two tools play a central role when it comes to ingesting logs from various sources. The sources landscape and various technologies used for log ingestion is highly dynamic. So there are tools like FluentBit, FluentD, and some modern log ingestion technologies where we could ingest logs from OT devices or API tools, right? So OpsBrew tries to reduce this operational overhead associated with managing the various log parsers by bringing a single control plane to manage and govern the log pipelines across the environment. And basically this is bringing a layer of abstraction on top of this log sources and log parsers. So here we're going to discuss a couple of challenges when it comes to log ingestion, right? So as I mentioned before, right, integrating and implementing this zoo of technologies is like it requires an ops team itself and parsing of logs. So writing parsing for different destinations or different format of logs, it's time consuming and requires labor to do this task. Then comes the log filtering. If you want to filter the logs with priority, so in scenarios like we have two SIEM, customer want to filter the log between the primary SIEM with the secondary SIEM. So all those filtering, it's have to do it manually. Then comes the log archival. So mostly any SIEM tool, once the log is ingested to the tools, it's like it's storing in a different format, and the raw log people are missing, which is required by the forensic or a purple team within an organization. Then comes the scalability, resilience, and high availability of this log ingestion layer completely. And as I've already mentioned, to fix all this required a huge skill set of people who understands different sources, ingesting log from sources, and writing the parsers and filters and scalability basically. Now let's discuss a couple of use cases that can be delivered through OpsBrew. First of all, it's a simple GUI-based log studio and a framework for onboarding structured and unstructured sources and source type. When we're talking about unstructured data, it's about OT devices or PCAP data that can be ingested into Azure Sentinel. Also, the processing of logs happens in the edge. It reduces the bandwidth cost when you're sending logs from on-prem to Azure Sentinel. The other use cases like, it's support OpsBrew enable the forensic team to keep the raw logs in object storage like blob. One of the other use cases, it manage multiple log parsing techniques through a single control plane, easing the manageability of governance of log pipelines in many-to-one or many-to-many scenarios. So we have seen those scenarios where customer using two SIEMs, like threat hunting team is using different SIEM, where SOC is using different SIEM. At the time of security modernization or SIEM modernization, the customer always want to keep some logs in their legacy or a traditional SIEM and move all the modern workloads logs or a cloud logs to Azure Sentinel. So Monitoring of log flow is other use case where we understand complete integrity, and we can create alert rules basically when comes to endpoint deviations. So the use cases like a Linux server is expected to send this much log, or a Linux server is down, the logs are not sending, we have a full visibility and any alerts if this endpoint have any deviations. The last point is like we will be discussing more on log enrichment, and please don't confuse with the enrichment that's happening at the Sentinel. So here we are talking more about enriching the logs for non-Azure endpoints like on-prem logs going to Azure Sentinel. We connect with third-party APIs to enrich this data.
Now let's have a quick demo on OpsBrew.
So first of all, I'm gonna create an environment and deploy OpsBrew collector. So our auto deployment supports all the hyperscale and on-prem. So we're creating a test cluster and upload the kubeconf file. Now the environment is deployed. It's called test n. And now we'll go to the pipeline console. So this is a pipeline console, and I'll be adding a pipeline. So here we will be giving the pipeline name as test pipeline. Give any description. In the pipeline console, you can see the environments on the left hand side and the sources we support. We have segmented the sources into network, application, cloud-based, and infrastructure. And also the destinations like visualization, storage, and SaaS tools. So basically, SaaS tools covers the other SIEM tools and Azure Sentinel. And here we're gonna add our environment in this pipeline that we have created. It's test-n, and we'll be adding two sources, one Linux and an APG gateway. So we have drag and drop both the sources, and we'll be setting up the connection parameters. So it supports two methods for collecting the logs, either syslog or beats. So we are selecting beats here. In the case of APG, there are two ways here, HTTP or TCP. So we will be using TCP for collecting logs from APG gateway. Let me set up the connection parameters. So it's JSON. I'll be taking logs from APG. Now I'll be adding the destinations. So here I'm going to add two destinations. One is Azure Log Analytics, which is Azure Sentinel backend, and std out. Basically, it's like to check the logs are coming or not, similar to tail manager. So I'm connecting OpsBrew collector with two destinations. So both the destinations have been configured, and we'll be creating the pipeline now. Before creating the pipeline, I'll testing the configuration. If there's any error, it will show no. Looks like it's fine. Now let's build the pipeline. Now let's find the IP address of the collector, OpsBrew collector. So if you want to know more about how the build logs, if there any error, you have to click the collector and find the build logs. So here everything is fine, or then the pipeline is built. and let's get the IP address of the collector where the endpoints forwarding the logs to. So I got the IP address of my collector. Now let's see the data is coming. So I'm gonna check the port logs. Port logs basically it shows it's like tail minus F for OpsBrew collector, finds out the logs are reaching the collector. So you can find two sources. See the logs coming in, and you could see that this cart number, this transfer. So we are taking data from the PG gateway, and you can see that cart number is coming in this log. Now let's see the Linux server logs is coming or not. So this is from APG, and you can see the Linux server logs also coming in. So we have created a tag for it. It's called Linux group, and both the logs are reaching OpsBrew collector. Now let's check the destinations. Custom logs and see the here you can see the logs are coming in log analytics as well. So now let me check the PG logs. Logs are getting collected in log analytics right now. So let's go back and check the std out. Now we're going to create a rule, a filtering rule in std out. So std out should have only RPG logs. Log analytics will have both RPG as well as Linux logs, but here creating a tag, creating a rule. Now we'll be masking the credit card. So as I showed before, you have the credit card information from RPG to log analytics. So we're going to mask that data. It's like PI data, which we're going to mask with some other fields. Great. And whatever masking we are doing, it's global, so we can use for any pipeline, whichever pipeline you are using in this environment. So now we have done two configurations. Only the Linux RPG logs will come to std out, and both the logs will come in log analytics, but all the PI information will be masked. So now we are testing the configuration again. And each time you do change any settings, you have to rebuild the pipeline. Again, pipeline is built. Let me check the build logs. So now you can see the logs, all the card numbers are masked. This is the output. So once the data get out of this OpsBrew collector, it will be masked, and all the Linux logs, you can now let's check std out where it is having only RPG logs. And let's check Azure Sentinel. So now let's check the logs in log analytics after the masking rules, and you can see that all the card number, the PI data is masked. So now we have shown a simple pipeline. Now let me show you a complicated pipeline. mostly in a real world scenario, you would have a traditional data center and a cloud-based hosting. And here you have OpsBrew Edge running in both the locations. And in the traditional environment, we have VMware, Linux, and Windows pushing logs to OpsBrew Edge, and OpsBrew Edge is pushing logs to three destinations basically. One is object storage and Azure Log Analytics, that is Azure Sentinel, and a traditional SIEM they are using. So it will also automatically redirect the logs. It manages the entire pipeline, and in case of cloud, they got a PG gateway running and some OT devices sending logs to OpsBrew Edge again, and a Kubernetes cluster running microservices. It's also sending logs to OpsBrew Edge, and these logs are sending to two destinations: object storage for forensic purposes, and log analytics for three different teams. Like the application team need the logs in different workbook. The DevSecOps or DevOps team need the Kubernetes logs in different tables, and SOC team needs in a different table. So I'll show you how it is done. So basically, OpsBrew will create without duplicates. It will store the log for the specific team in different tables. So let me show the monitoring dashboard. So here you can see the monitoring dashboard and can see the log flow. So from Kubernetes, IoT, RPG, Linux, and Windows to destinations. So you can see different workbooks where we have keep the logs so that each team members can access their logs. Like as I mentioned before, DevSecOps team or forensic team. Next one is enrichment data. So this is mostly for use cases where non-Azure workloads sending logs to Azure Sentinel. We can enrich a log with a third party. So we can give the field name like client IP or IP address. It will be, this data will be enriched. So mostly from an on-prem environment, if you want to push logs to Sentinel, this data can be enriched. Not for cloud, for non-Azure logs basically. Pod logs we have seen, it's just like tail manager, and get IP is mostly to get the IP address of the edge for the agents to send or forward the logs. And bid logs that we have seen is mostly when creating the pipeline. If there is an error, you can find the logs there. Auto scaling, if you want to scale the environment like the edge, you can put rules here with the CPU, average CPU usage and all, it automatically scales. So you don't need, there is no manual intervention here, it's auto scaling. Now, in case of Azure Sentinel, what we have is that we can, depending on each endpoint, we can create Sentinel rules. So custom rules, so you can connect to Sentinel, it will give you the kind of use cases or alerts can be achieved through Sentinel. You can enable it here, it will automatically update it in Azure Sentinel. So the moment you are adding an endpoint, it will give a recommendation, like what all rules can be applied. So here we are going to apply some rules for the Kubernetes logs, like threshold alert, and this will be updated in Azure Sentinel automatically. So let me go to Azure Sentinel and show that this rule is applied. So you can see that this rule is automatically updated. So similar to that, based on endpoint, it will give a recommendation of Sentinel rules. So you don't have to do it in Azure Sentinel. You can do it from here the moment the pipeline is getting created. Thank you, Microsoft, for giving us this opportunity to speak at Ignite community. And thank you, Microsoft MIA team, for the tremendous support for OpsBrew. And back to Nicholas.
Thanks, Arun. That was a really awesome demo. And it's awesome to see fellows like yourself contributing to our community. And I look forward to more in the future. So let's wrap up and just recap really quickly. We've covered in these two sessions the Azure Sentinel best practices. So this will allow you to quickly deploy Azure Sentinel in your environment and meet the requirements for your environment. Thank you for joining us, and we look forward to deploying Azure Sentinel in your environment. Have a nice day.